Good morning, everyone. This is Pushkar Apte from Semi. Welcome to the AI data webinar series. Today we'll hear about blockchain and manufacturing, a smarter way to drive efficiency in the semiconductor and electronics supply chains from Nelson, the CTO of TIPCO. And he will be on in just a few minutes. I will get us started with a quick introduction to Semi and what Semi is doing in the area of AI and data. So Semi has a strong initiative in data and AI, and of course we are an industry association, so our job is to ensure the success of the industry as a whole and make sure that all ships rise. What we're trying to provide is platforms to help the industry realize the full potential of smart data and AI. In the initial conversations we've had with several companies, what we've heard is that a major challenge is data communication and data sharing because of very valid concerns about IP security and so forth. And we want to make sure that we work with our members to find ways to overcome these challenges and realize the full capability of AI. Again, in the spirit of being an industry association, we have 4 pillars to our effort, to our initiative. The first is education, which is essentially engaging with lots of experts in this field and bringing them to the members. We've had over 50 presentations just in 2018, and we have probably had about 20 in 2019 already. We're also working with some members for proof of concept demonstrations. For example, going back to what I mentioned earlier about figuring out how we can overcome the IP and security concerns and share data so that AI can be used for manufacturing process optimization. And I think we'll hear some other aspects of that from Nelson in a few minutes. We're providing thought leadership and building technology communities, and of course, Semi has the standards and market reports and so forth. Smart data and AI, of course, is just one way to get involved. Semi is a multifaceted organization with the facets increasing by the day. Literally, we now cover the whole electronics value chain, including the Electronic System Design Alliance, the Flex Tech. We have the MEMS group and so forth. And as you can see, there's a whole bunch of different activities that have come together under the Semi umbrella. Just a quick snapshot of what Semi is. We have over 2,260 members, several programs, lots of standards. We reach and touch over 1.3 million people. We have 20 plus technology communities, and we're active in a whole variety of areas, as you can see, ranging from technology to workforce development, standards, and so forth. Finally, I realize that most people on this seminar or webinar are probably Semi members. We welcome you to engage with Semi. You could publish a technology blog through Semi, where these are some of the topics that are of interest, and specifically from the smart data and AI perspective, but there's a lot of others. These topics are just examples, not by any means comprehensive, but things like AI, IoT, the different processing architectures that are coming up, advanced sensing, heterogeneous integration, and so forth. And our director of marketing, Heidi Hoffman, she's actually here in the room, and her email is up there. Feel free to contact her if you would like to engage by having a blog. And in fact, Nelson and the TIPCO team actually had a blog just earlier this month or last month. With that, let me hand it over to Nelson. Just a few Yeah, so we really welcome you to get involved. You already had Heidi's email on the previous slide. You have my email there, and Mike Szynski, who is the director of technology communities, his email is also up there. Feel free to contact any of us to work on this. Now, a few logistics. All attendees will be muted through the webinar. You can add questions to the Q&A box in the control panel as up there. This webinar is being recorded, and you will receive a link later. And I think with that, we will move on to Nelson. You can see his bio up there, and I think I would rather not take up his time. I spoke to him briefly. I understand he's in Calgary, and we're lucky to find him on the ground because apparently he's on a plane most of the time, if that's right, Nelson. So without further ado, Nelson, take it away.
All right, sounds good. Thank you very much. Yeah, planes are essentially my life, so but that's all right. Okay, well, let me just pull up the slides here for everybody. All right, so hopefully that looks okay, and hopefully you can hear me fine. As was mentioned, we're going to talk a bit about blockchain today, and I shortened the title. It wouldn't fit on my slides, so I made it a little shorter, but we're going to talk about blockchain. We're going to talk about a little bit about what it is. We're going to talk about use cases, and then also some things you need to think about if you're looking to adopt blockchain for enterprise use cases. One slide just in terms of who TIBCO is for people that may not be familiar with the organization. It's a global organization. It's a software company based in California, been around for 20 plus years, really focused on the technologies related to integration, as we call it, as interconnect everything. So this can be IoT, integration, APIs, microservices, all the different concepts in that particular space. And then, of course, we also have a whole area of the company that deals with analytics and data governance and management. So that can be advanced analytics, AI, ML, that can be data virtualization, that can be data fabrics on top of a big data environment, a number of different capabilities in that area. So we really work on bringing these two technology spaces together and provide solutions for customers in a number of different verticals, including manufacturing. So let's take a look and see why people are thinking about blockchain. So blockchain, for a while, there was a lot of hype around blockchain, and a lot of it, I think, had to do with the cryptocurrencies. People were writing half of a white paper and making millions of dollars just on the promise of what the cryptocurrency token associated with that was going to be. But of course, that has died down a little bit, which I think is a good thing. And now there's a lot more focus on the applicability of blockchain as more of an enterprise platform and the use cases that are valid for that platform. As we'll see, not every use case is valid for a blockchain, but there are some use cases that have a lot of interest, and there are some use cases that could provide a lot of value. And so one of the things that people are looking at is this idea of highly connected interactions. So as we build out our networks, and not just our social networks, but as organizations are building out deeper, broader, integrated networks, whether it's across the supply chain, other types of partners, people that they're doing business with, and so on, we need to deal with that, and we need to deal with that efficiently. And some of the traditional methods, FTPing files, or even some of the newer methods around point-to-point API invocations are simply not sufficient. So this is one area that people are looking at. They're extending that a little bit with this idea of a decentralized business network. And I typically refer to this as just a new way of doing B2B. So if I need to exchange information with my partners in a way that is much more seamless and streamlined, I could potentially look at blockchain as a solution for providing that capability. Right? So I want to automate the exchange of transaction or asset information. I'm going to automate how organizations are going to respond to that through the use of things like smart contracts. I'm going to provide a certain level of tamper resistance as part of that network. So those are all different aspects of what organizations are looking at. And so using blockchain to build a decentralized business network has a lot of interesting concepts associated with it. And then finally, as we build these business networks, and as we have these very highly connected, event-driven, real-time interactions, You have to do that with, of course, a certain level of integrity, security. You want to make sure that everybody agrees that the transactions that are being added to this network are valid and agreed upon. And you also need to make sure that you have the right level of visibility. Are you going to allow everybody to see all the data, or are you only going to allow certain people to see certain aspects of it? So these are some of the enterprise drivers that I tend to find when I talk to organizations. Highly connected interactions, the need to streamline processes and data transfer across multiple partners, and do so in a way that has all those abilities, right? Security, verifiability, and so on. And these have lots of different use cases across lots of different verticals. So whether you're talking about verticals that are dealing with government, whether you're talking about verticals dealing with the consumer, healthcare, and so on, a lot of different use cases across a lot of different verticals. And of course, that also applies to the manufacturing space as well. So whether I'm looking to build out a solution to improve regulatory compliance, to streamline research and development, to make sure that I have the right operations happening in my manufacturing process, to get better end-to-end visibility into my supply chain. These are all different aspects of how blockchain could be utilized within the manufacturing vertical. So we can kind of break that down a little bit further. So of course, today we're going to touch on some of those. We're first going to start off though with a core concepts review. This is not meant to be a full-blown review or detailed walkthrough of what a blockchain is, the technology behind it, and so on and so forth. I will touch on some of the key terms, but the walkthrough itself could take an hour, and we have separate sessions on that. But I will kind of give you an idea of what some of the core concepts are. Then we're going to talk about different manufacturing use cases, and I've kind of broken it down into different stages. So what are some use cases before production? What are some use cases that could be applied during production? And then, of course, what are some use cases that apply after production? So we'll talk about some of those. And then we'll also look at some enterprise considerations. So when you deploy a blockchain, what else do you need to think about? What are some of the got-yous? What are some other aspects of an overall enterprise architecture that you need to think about? All right, so I'll touch upon some of those based on our experience working with a number of different customers. All right, so just a quick review. Blockchain itself, for people that may not be as familiar with it, this is not meant to be a blockchain cryptocurrency trading presentation, so we won't get rich, at least immediately overnight, by following some of these things, but hopefully this will give you an idea of more of the core foundation of what a blockchain brings to the table. So many different ways to describe this. I've tried to distill it down into sort of 4 key points. And really, when you utilize it, when you think about these 4 key points, I put them in the context of almost like a distributed data management platform, right? So you want to utilize these capabilities to share information across that distributed business network I referred to earlier. And again, I need to do so securely and with potentially some business logic baked into that network. Right, so the idea here is that I first start with a distributed system of record. So one of the core concepts behind blockchain is that there is no central database. So by default, and again, this is going to vary fairly, can be greatly depending on what type of blockchain technology you're using. But just generally speaking, you have a completely distributed set of data, and all information is copied to all the nodes. Right? So there is no central database. If somebody adds a record or a transaction to my ledger, then that transaction can effectively be copied to everybody that's running a node. Right? So you all have visibility to that data. Now that can be good and bad. Right? We'll talk about some of the implications of that. You have to have a certain level of security, verifiability, provenance. So this is the ability of blockchain to really provide a more tamper-resistant environment for storing information. So first of all, there's no central database, so there's no central place for a person to attack. You also have visibility across the entire network, so some malicious actor can't go and just update a record in a database, and now that becomes the source of truth. So there is that certain level that blockchain provides by the fact that it is distributed. It also provides this idea of being able to take a block of information, which is a set of transactions, and effectively have that block point to the previous block via a set of hash codes. Right? So these hashes are effectively unique fingerprints that represent the data. And so the idea here is that if somebody were to change a transaction in that particular block, well, that hash code would no longer be valid. So you would quickly be able to identify the fact that someone has tampered with a piece of information. And so that's where the blockchain kind of component comes from this particular concept. Then you have this idea of embedded business terms. So this is the notion that I can add effectively programs to my overall blockchain network. These programs are referred to as smart contracts, and they really do represent the business logic of the network. So if someone adds a new transaction, I can actually then apply business logic against that transaction and cause something to get triggered automatically. And then finally, as you build out this network, you can imagine I'm adding all these transactions. I need to make sure that those transactions are valid and agreed upon. And so there's this notion of consensus, right? There's different consensus algorithms. And these consensus algorithms dictate what is actually a valid transaction, right? How many participants have to be able to validate that transaction before it's added to the network? And how do you know who those participants should be? Right? That would be a couple of considerations related to this particular concept. So it's a distributed data management platform, typically has those principles. There's a lot of nuances to this and a lot of extra variations and other concepts, of course. But at its core, this is some of the things that we're really talking about when it comes to blockchain. And there's this notion of permission blockchains versus permissionless or consortium blockchains as well. So the idea here is that with an enterprise, you typically know who's joining your blockchain network. Right? You've allowed them into the network. You're allowing them to participate in the overall exchange of information. And so that's much more of a permissioned or consortium blockchain. Permissionless is going to be more like Bitcoin. Right? Anybody can join, anybody can run a node. It's somewhat anonymous, and it's really more open in this particular sense. Right? So that's more of a permissionless blockchain. Permissioned or consortium tend to be what you see in the enterprise space. As I mentioned, smart contracts are a way to introduce business logic. So again, there is no central database. There's no central coordinator for all this business logic. Each of the nodes themselves will actually run that smart contract. There is this ability to say, well, everybody then has to agree on the results of the smart contract execution. If they don't agree on the results, then that transaction can effectively be marked as invalid and not get written to the ledger. Right, so just think of smart contracts as the business logic. Now, are they smart? And they're only as smart as the programming logic and whatnot that you put in the code. And are they contracts? This is where it gets a little bit interesting because there's this notion of, well, are smart contracts legal contracts? And I know that there are certain actually countries that are putting regulations in place where smart contracts, the contract part, is going to be treated effectively as a legal contract. So that's something that's still up for debate, still a little bit up in the air. Okay, a couple of other things. One is the concept of an oracle. So if you can imagine that if I have a smart contract that needs external data, how does it get that external data? Right, the smart contract is not just running in a single location, it's running in multiple locations. If I'm accessing external information, how can I make sure that that external information source is trusted? Right, so these are some of the kind of considerations that you need to think about when you're using smart contracts. So an oracle is meant to be that trusted external source of information. And there's many different flavors of this. I can have it be based on some software principles, can be hardware based, so baked into an IoT device directly as an example, or it could be even consensus based. If I reach out to 5 oracles and 3 respond with the same answer, I'm going to take those, that particular response as the trusted response. But this is just the idea of being able to bring outside information into the blockchain network and use it as part of the overall execution environment. Then there's also this idea of zero knowledge proofs. And zero knowledge proofs are effectively being able to prove something without giving all the data or all the information as to how you were able to prove it. So it's a more of a mathematical approach to really proving a transaction and the validity of that transaction without revealing all the information about the transaction. So as you can imagine, this is very big in things like finance and insurance. It's also big when it comes to things like identity, right? Especially personal identity. How do I prove that the person is who they say they are without passing around personal information? Okay, so those are just some concepts. Hopefully that helped everybody get a little bit of a picture in terms of what a blockchain really is at its core. Now let's take a look at some applications. Right, so some use cases, whether again I'm talking about pre-production, production, or post-production. Number of different use cases and potential applications for blockchain in each one of these stages. So again, if we go back to the idea of blockchain being a network, I can have a number of different nodes, and those nodes are typically going to exist at different organizations, different distributed business units within a single organization potentially. A blockchain network with a node of one is probably not going to be overly exciting. So they do tend to be somewhat distributed and involve multiple parties. But the idea is here is you have all these nodes. They do know how to talk to one another. They each have their own copy of the data. I talked about there being no central database. And the idea is that if somebody adds a transaction into that node, whether it's a transaction around intellectual property, whether it's a IoT sensor reading for the purposes of tracking a good as it moves through a supply chain, or in a case of distribution where I want to make sure that I know where my product is going and hasn't been tampered with or isn't a fraudulent product. I add that information to the node, and then other actors, other participants in the network will then have a copy of that information I'll call it near real time. We're dealing with a distributed system here, so all the things around being more eventually consistent, I guess, if you put it in database terms, that would be the consideration here. At some point, everybody will have a copy of that particular piece of data. And then, of course, you can write smart contracts to execute upon that transaction automatically. Right, but that's the idea. Somebody adds a transaction or submits a transaction into the network, and then it may go through a certain set of stages to make sure that the transaction is valid. You run a consensus algorithm against it, make sure everybody agrees, or at least the way that the network is governed, it agrees, and then everybody gets a copy of that information. So if we take a look at a particular use case then in this scenario, specifically around IP protection, we know that this is a big deal. So intellectual property theft is costly, right, and for a number of different reasons. So definitely something that is in an area that one can look at. And we all know the effects of stolen intellectual property. So whether it's related to lost revenue, whether it slows down the process of innovation, the cost, even damage to a brand, there's a lot of different impacts, if you will, to intellectual property theft. Of course, it being digital these days, it's easy to copy and steal, and it's very difficult to track, and it's also expensive. And so in a lot of cases, smaller organizations don't really have a chance to do much about it, right, if they find out that a particular piece of intellectual property has been stolen. So if we put that in the context of blockchain, so you can think about there being different actors. So you have people that are generating IP and people that are potentially wanting to acquire or buy IP. And so the idea here is that I could have some sort of encrypted IP asset. Now, depending on what this is, this could be quite large, right? So the intellectual property or whatever the digital form of the intellectual property is could be fairly substantial. And so you may not put everything on the blockchain. You may actually have more of a pointer. So you'll take some metadata, you'll hash it, you'll hash the information as well in the IP asset. You'll put that all together and you'll put that onto the blockchain, which effectively acts as a pointer to some kind of off-chain storage. Right? So you're still trying to make sure that if somebody does tamper with the original source, that then the hashes won't match, and then you can maybe pick up on the idea that somebody has messed around with that intellectual property. But the idea here is that we want to use the blockchain as a way to distribute that information to everybody that's participating in the blockchain network. So in this particular case, you have, again, no central database. You want to build a certain capability around auditability, traceability, all those kinds of things into the network so that people know who owns what and who purchased what. You want to make sure it's encrypted, hashed, and so on. All the records are timestamped, so you know exactly what happened when, and use it for things like usage or rights tracking, and even things like payments. Right? If you wanted to automate payments through some sort of form through the blockchain network itself. So the idea here is you would first have a verified owner, and that's actually the first trick. How do you verify that the person submitting the IP to the blockchain network in this case, how do you know that they're actually the original owner? So you have to first verify that somehow. There's still no magic here. I mean, there's still certain things that you need to take into account when you're doing this. This is no different from in the property management space. How do you verify that a person is the original and the right owner of a piece of property, right, before you actually start to use a blockchain to manage transfers of that property? So you do have the idea of a verified owner. Again, they're going to encrypt the content, whether it's all the content or a hashed version of it to create some pointers and so on and so forth. So you're going to encrypt that, and you're going to store that on the ledger, right? So now the ledger actually contains this notion of an IP, and it's been verified and validated that that person actually does own that IP. Now you can have somebody then say, well, I would like to acquire, purchase, whatever it is, that particular IP asset. And so they're going to request the exchange, and they're going to give a set of keys to the owner, right, that person has access to. So that owner can re-encrypt the information with those new keys. That then gets added to the ledger, to the blockchain. And now you're going to need to kind of manage through more of an atomic transaction, this information and key exchange. So what you want to do is make sure that the keys that you're using, you don't give the buyer all of the keys until they've effectively paid for the information. But you don't want to just have it so that they pay and that you don't get the content, right? So you're trying to manage that through the blockchain network itself. And you can do a lot of that in an automated fashion through the use of smart contracts. So eventually, once the exchange happens, you now have the key that's given to the buyer so they can decrypt the content. And then the fact that they've even done that is also written to the ledger itself, right? So there's this really using the blockchain as a way to distribute keys in this particular case, but some mechanism that allows buyers and IP owners to collaborate, share, and to exchange information in a way that is all recorded on the blockchain network so that I know what happens. Right, so this is one example of how a blockchain network could be utilized to essentially facilitate the better protection of intellectual property. So moving on to something like preventive maintenance. So the first thing you typically will have is some sort of sensor or a set of sensors that are producing information from a piece of equipment. So it could be things like temperatures or pressures or whatever that happens to be. I have some set of IoT devices producing data. Now the first trick here is I need to make sure that the IoT devices are who they say that they are. And so you can do things like right when the IoT device is first manufactured, you effectively bake an identifier into that IoT device. And that could get recorded on a blockchain, right at the point of manufacturing. And then through some mechanisms for sort of attaching that particular signature to the characteristics of the device, you can then know if the device has been tampered with. Right? So that's one of the first things. You need to make sure that the IoT device is who it says it is. And when you're dealing with preventive maintenance use cases, as these IoT devices are generating data, you tend to look at how you're going to pre-process that data. Right, so you may do some filtering, some transformations, some stream processing, streaming analytics. You may apply an analytical model, for example, a TensorFlow model at this point, maybe to do some localized processing. Maybe you're going to try and predict that an issue with that piece of equipment is going to occur, right, based on its pattern of what you're monitoring. So those are all things that you can do out at the edge in a pre-processing context, making sure, of course, that it's doing so securely. That pre-processing context may forward information to the blockchain network. So for example, if I wanted to then record the fact that, I don't know, maybe you took a snapshot or you're recording snapshots of device information periodically, or maybe the predictive analytical model has determined that there is a potential problem here, and so you need to make sure that everybody in that network is aware of that potential problem. Maybe it's the supplier of the device, the organization that's running the device, and maybe some even downstream participants. Right, so you want to be able to generate that information, push it to the blockchain, and potentially have some logic run against that. Right, and that information, of course, will go to other participants, as I mentioned, so that they can respond appropriately. So you may do things like kind of predict outages based on past history. As I mentioned, you're going to pre-process all this as streams. You're going to apply rules against this data, so on and so forth. If you do identify a problem, you could track the resolution process against the blockchain. And then also you can build out a complete history. So what is the maintenance history? Who owns that particular device? Are there any recalls? Do I have to conform to some sort of regulatory set of considerations, right? So one of those nodes could be a regulatory body, right? And they have immediate visibility into everything that's happening in the blockchain network. So that's the idea. So you're trying to almost merge concepts around IoT, AI, ML, and the blockchain in order to provide a much more streamlined exchange of information as it relates to preventive maintenance in this case, or it could even be something like just supply chain and distribution. And that's actually a lead into the next use case. It's really around where did that product come from, right? So as a product moves through different stages in its journey, I want to be able to track and make sure that that product is coming from where I thought it was coming from, and it was also handled properly, as an example, right? So typically when you look at building an end-to-end view of an asset across all these different participants, what people will do is they will tend to use APIs to try and do so. So there'll be an exchange of information across different parties. They may exchange files, they may make API calls. Everybody ends up with their own copy of the data. That data is really not synchronized. So then people try and put it into a central data store, which has its own set of problems, of course, even around things like security and ownership and who runs it and how do you verify that, again, the information hasn't been changed. So this can be quite complicated, right? And it can paint an incomplete picture. And so if you look at it, blockchain could potentially be used in this case as well. So again, if I have IoT devices or I have people inputting information into the blockchain, that could be one way to make sure that the information is kept up to date, accurately fed with data, and then done so in a way that's completely distributed. Now, again, you need to make sure that those IoT devices are who they say they are, right? So the blockchain is only going to be as good as the information that you're giving it. That doesn't change. And so that, of course, is a problem that needs to be addressed. But then once the information is put into the ledger, you're now building out this non-centralized, agreed upon, secure track and trace ledger of information, right, is the way that I tend to look at it. And that information, of course, can be further enhanced through the use of things like smart contracts. And so that is another potential way that blockchain could be used. And so you're really, again, bringing together blockchain with IoT, and you're turning different manufacturing processes and context into more of a, quote unquote, smart device-driven process, right? And the smart here refers to the use of smart contracts. not necessarily that you're making it a whole lot better, because just because you're using technology, of course, doesn't mean you can't hurt yourself. But the idea here is that you could build out this network, combine concepts around IoT, AI, ML, and blockchain, and use it as a way to streamline a lot of the use cases that we have just talked about. Okay, so you're trying to make it a much more collaborative process. As I mentioned, in some ways, it can be thought of as a better way to do B2B. You're trying to make it more secure. You're trying to make it more real-time. You're trying to make sure that you can automate how you are responding to the transactions, that they're agreed upon, and really you're trying to use it, again, as a way to kind of improve the flow and accuracy of the information, right, as it relates to these different use cases. Okay, so let's take a quick snapshot here, just a couple slides on the role of consensus, because this is a very important aspect of blockchain as well. So if I do have a full network of participants, how do I make sure that they all agree that the transactions that are getting added are valid transactions? So, and consensus here, people may have heard of proof of work. Proof of work is typically what is done when it comes to Bitcoin. So you'll hear about miners, and you'll hear about effectively a mathematical guessing game that these miners have to hit before they can go and add their block of transactions to the ledger. And the idea is that, of course, this workload is being spread across different miners so that no one miner has full control over all of the consensus, if you will. If they did, then, of course, they could pretty much do whatever they wanted to do with the transactions, ignore the transactions, potentially alter the transactions, I guess, and so on. But so the idea here is when you look at from an enterprise context, proof of work tends to not be the way that people will approach this, right? There's a number of other types of algorithms that people will look at, and I'll pop up a couple here in a second. But generally speaking, though, the idea here is that you're trying to make sure that all the participants agree on the transactions. Right? Now, all may not be physically all of them. It may just be however many you need in order to validate a transaction. Right? So it's not like 100% of the nodes or 100% of the participants have to validate it. It may only be a subset. And again, that'll be based on things like the algorithm that you select and the way that you govern the network. You can also have things like, well, I can utilize consensus to figure out who can join the network. So it may not just be around the transactions themselves, but it may also be around who can actually join the network and participate in the network. And so you'll hear about things like a voting mechanism where the other network participants, or maybe the majority owners, people with the most stake in the network, whatever it happens to be, can actually vote on whether a new organization is allowed to join. So in some ways, you're using the automation of the blockchain network as a way to govern the network as well. Okay, so these are just some examples, some of the more popular ones, if you will. So proof of work, I talked about that. Proof of stake is where effectively you are managing the blockchain network via a form of stake, right? So as all the participants join the network, they put some sort of, well, it could be effectively money, into the network itself, right? And based upon how much money you put in, that's the weighting or the stake that you have in that network. Right? So it's a slightly different mechanism. The idea being that if you act maliciously, you would lose your stake. Right, so that would be one way to look at this. Proof of elapsed time, this is just more making sure that the nodes wait a certain amount of time before they try and validate a set of transactions. Right, so again, the idea here is you're trying to distribute the validation strategy or the validation algorithm or whatever it is to different participants in the network. So again, not one person is controlling the network. But there's a bunch of these. So these are just a subset. I'm sure there's more. These are just the ones that I've kind of run across as a person reads and looks at different articles and so on and so forth. There's also a lady from Forrester, Martha Bennett. She's been following blockchain for a long period of time. She's collected this list, so I have to hand it to her for providing a lot of this information as well. But there's obviously a lot of different ways you can do this. So there's no one way. So when you are selecting a blockchain framework, you really need to understand what kind of consensus algorithms it's going to support as well, because that's going to govern a lot around how that network itself is going to behave and execute. Okay, so now that we know a little bit about blockchain, we know about some of the use cases around blockchain, let's take a look at what it kind of takes to implement blockchain. Right? What do you need to think about? What are some considerations? I think of even maybe, if I've got some myths in here as well, actually, so we can talk about that. So one of the things that people often say when it comes to blockchain is that there is no third party. Right? There's no third party. So if I'm in the banking industry, for example, I can get rid of all the banks because all the exchange of information and money is going to be done all automatically with no third party. And so that is something that, of course, you will hear about. Now, realistically speaking, when it comes to enterprise blockchains, again, I'll stay away from Bitcoin and some of those crypto-related blockchains for the moment. But realistically speaking, from an enterprise blockchain perspective, you will have some third party, and that third party tends to be some sort of governance structure that is facilitating the execution or the running of the network itself. All right, so this is guidelines like who's allowed to join, under what set of considerations are you going to effectively reject a participant from the network? What happens if someone doesn't behave according to the rules of the network? How do you back out of errors? So if somebody submitted a transaction and you had a smart contract programming error, well, how do you back that out, right? The distributed ledger is immutable. You cannot delete from a blockchain ledger. So, and that, again, that's good or bad. You have a complete history. You can't alter anything. But that means you also can't alter mistakes, at least not directly. So then you get into the idea of issuing compensating transactions and so on and so forth. But you do need some sort of governing body that's going to manage this. And this is one of the reasons why you will hear about a lot of blockchain proof of concepts. They make a lot of press releases and all this kind of goes on, and then you never hear about them afterwards. Or the number that you hear about is a very small subset. And in many cases, the reason is that it takes a long time to get all those participants to agree on how they're going to run the network, or even just to find them and get them to join. Right? That takes time. It's not really a technology problem. It's just the building of the network itself. And so that no third party really means that there is a third party. It's just there is no central database. There's no central coordinator of all your business logic, things like that. That can be true, but you're still likely going to need somebody to run it. The second one is, I've heard the comment, well, I put the information on the blockchain, so that means it's secure. Like, well, no, not really. Just because you put it on the blockchain doesn't mean that it's encrypted. And second of all, you need to make sure that people can only see the information that they're allowed to see. Right? I mean, I know we've talked about by default everybody getting a copy of all the data, but realistically speaking, from an enterprise blockchain standpoint, you only want certain people to have a copy of all the data, or just the data that's relevant and viewable by them. Right, so different blockchain frameworks will approach that differently in terms of how you can set that up. But realistically, not everybody's going to see all data. They're only going to see certain aspects of the data. And then finally, this idea of it being immutable. I try and stay away from a blockchain as being immutable. I will call it tamper resistant. And Martha from Forrester and I have conversations around this all the time. But the idea here is that it's not fully immutable. Again, you have to deal with mistakes, so you have to kind of deal with how you're going to back out of certain things. How do you make sure that the data that was put onto the blockchain is valid in the first place? So we talked about that in the context of IoT. But there's also this notion of a fork where I can effectively go back in time and start the ledger off of a new branch almost, is the way to kind of look at it. So you can get hard forks and soft forks and things like that. So there's different ways in which you can actually effectively branch off the ledger kind of before the mistake itself actually happened. And you see this a lot in the cryptocurrency space, the public side, especially with technologies like Ethereum. So you do have that aspect. So, you know, again, it's not fully immutable, but it's very tamper resistant. So it just makes it easier for you to detect that somebody's messing around with the data. So those are some of the considerations. So you need to look at how you're going to run the network, right? What's the governance model? You need to look at things like data privacy. You need to look at the legal aspects of this, our smart contracts, legal contracts. You need to figure out how you're going to manage the network itself. So I now have a completely distributed set of technology that's running across multiple participants on machines that I don't even own, right? So how do I manage that? How do I make sure that all my upgrades happen appropriately? How do I even detect the fact that a node went down, right? Things like that. So those kinds of things you need to consider. And then also, this is a new and emerging space. I mean, the technology is changing very, very rapidly. Lots of new players emerge. And so if I'm building a blockchain solution, how do I pick a winner? Right? I don't want to have to, you know, in 6 months or a year or whatever it is, I don't want to have to go and rewrite the entire blockchain solution that I've deployed, right? Just because that particular technology, whether it's open source or not, you know, it just happened to not be the one that the general market selected, or there was a new entrant that then went and took over, if you will. Now, having said that, it's likely going to be that as enterprises start to look at this technology and adopt it, that you're going to have more than one, right? Because just like with databases, you have relational databases, NoSQL stores, and so on. They're optimized for certain use cases. Blockchains themselves, it's going to be very difficult for a single blockchain to be optimized for all use cases. And so you're likely going to have more than one, right? And the more than one is really because you want to optimize the use of that blockchain stack for the use case that you're tackling. So IoT and micropayments may require a very different blockchain framework than something that's more around IP and IP protection. Right? So now you'll have to then exchange information between those two, but that's a different problem. When you're dealing with smart contracts, we talked about a little bit around things like programming errors, right? How do I deal with programming errors? And again, it's not just me now, it's a number of participants. So I need to have a certain level of collaboration that I need to think about. Again, how am I going to do upgrades? How am I going to make sure that the code actually represents the rules of the network? How am I going to run it? Again, the legal implications and the lack of standards, right? Because this technology is so rapidly evolving, every blockchain stack effectively does it in a different way. So the concepts, at least at a high level, are the same, but as you drill down, they're all going to implement what they think is a blockchain in different ways. And we looked at, just the consensus algorithms alone. There's dozens of those. Never mind the actual rest of the environment itself. So something we also need to be aware of. Now, unless we're a startup, we also have all of our existing enterprise systems to think about. And chances are we're not just throwing away those systems overnight. So we also need to deal with that. So I'm not going to put a blockchain in and that's going to be the only thing I'm going to have, right? I'm still going to have mainframes, I'm still going to have applications, I'm still going to have all that other stuff. And so I also need to think about how I'm going to integrate the blockchain into the rest of my environment. So I've been on a lot of POCs where the POC is done, and then the next thing that comes up is well, that's great, but this information is coming from my mainframe. How do I get that into the blockchain? Or how do I take a blockchain transaction and get that back into my ERP system? Right, so I need to deal with that. My smart contract logic, that business logic is not going to be my entire organization's business logic. So that, of course, needs to be synchronized and made consistent with the rest of my enterprise. I want to make sure that everything's event-driven. So if the purpose of blockchain is to streamline and automate the passing of information and transactions around a distributed network, I don't want to have to turn that into a batch-based, kind of polling-based system. If something shows up in the blockchain of which I'm interested in, I should be notified of it immediately and then automatically have my back-end systems respond to that. I have all this wonderful data now that's potentially on the chain in the ledger or partially on chain and partially off chain, right? In the case where the data sets are too big for today's ledger and blockchain technology. So how do I do analytics on that? Right, I've got all this wonderful information about my supply chain, but I need to be able to analyze it and make sure I can identify where things like bottlenecks are occurring. And then finally, blockchains are going to have APIs, but I'm not just going to open those APIs up to anybody. So I need to make sure that they're managed, they're governed, and that I am controlling access to how the blockchain itself is being utilized, right? Whether that's, again, through people or through automated enterprise systems. So those are just some of the challenges that you tend to run across. There's many different ways to draw these diagrams. This is how I chose to do it here. So I really start with kind of blockchain as that core kind of platform, if you will. And then on top of that platform, you're going to layer certain capabilities. So whether you are distributing the data to and from the blockchain, whether you are integrating that information through the use of microservices and so on to other systems, whether you're managing those APIs, whether you're doing analytics, handling the events, right? And then, of course, combining that with off-chain capabilities like edge processing, storage, even outside logic, of course, and things like identity, right? That can all come into play here as well. So different ways you can draw this, and this is just one of the ways that I've tried to represent some of the higher level technology constructs that can support a blockchain deployment. And so from our standpoint, this is a lot of what we focus on, but the idea here is that you do want to think about those other aspects and make sure that you're not just thinking of blockchain as a black box, right? It needs to be tied into the rest of your organization. Just one point of interest, we do have a open source labs project called Project Dovetail, which is really focused around the ability to author smart contracts. So we try to bring a model-driven approach to smart contract development and make it easier for people to consume blockchain technology and also write the business logic for blockchain technology, and do so in a way that doesn't necessarily tie you to a particular framework. So if you did want to move to a new technology, it would be easier to do so. So just something that we've been working on. There's an initial release of it on GitHub, and so people can kind of look at it, try it out, provide us with feedback. The idea here is we're trying to build out a bit more of an open source community around smart contract development. We see smart contracts as a key piece of a blockchain deployment because it does actually hold your business logic. We do have a number of meetups on this, so you can always join our meetup community and get more information on some of these sessions that we do. And then there's a couple links here that you can go to just to read up a little bit more. There's a white paper that actually describes that diagram that I showed you, just what those pieces are, and things like that. But so feel free to check out some of those links as well. And with that, I should be able to take some questions.
Thanks a lot, Nelson. That was a great presentation. I'm just taking a moment to read your cartoon there.
Yeah, that's always a good safety tip. Read the cartoon before you ask any questions.
Exactly. Well, we have some questions. Let me sort of get started with, and to the people who ask questions, we have a bunch of questions, so we may or may not get to all of them, but you can still, they will still be forwarded to the speaker. The first question, Nelson, in the preventive maintenance scenario, it's unclear who the parties are in the smart contract. Could you please illuminate?
Sure. Yeah, so with preventive maintenance, the idea here is that you could have participants such as people that are running a piece of equipment, so they may actually be part of this overall network. I'll use vehicles. Vehicles are a good use case here. So first of all, when you make a vehicle, there's obviously parts coming from a number of different suppliers, right? So you can actually track the provenance of those parts through the use of something like a blockchain. Then you've got the process of actually making the vehicle. And so you've got parts being put on the car, you've got equipment and robots and things like that that are, again, installing those parts. And you may be actually trying to detect things like, well, is there vibration on this robotic arm? This is an actual use case, that's why I pick it. But how's my equipment performing? Can I use sensors to try and predict that a piece of equipment is about to fail? Or maybe there's some piece of equipment that is out of spec, and so the work that it's doing on this particular vehicle isn't going to match or meet my my KPIs and so on and so forth. So that piece of equipment, of course, you want to track its overall history. And so where did it come from? How is it maintained? And so now you've got the supplier of that piece of equipment, you've got the organization that could be separate that maintains that equipment, and then again you've got the party that's actually using that equipment. And then once that vehicle leaves the factory, it in itself has now a complete history. So it obviously gets shipped somewhere, hopefully it gets purchased, that person keeps it for a while, in theory maintains it, and then sells it to somebody, and now I've got a recall, right? So that recall is now, you got to backtrack all of that and say, well, where did that actually come from, right? Which piece of, which part was installed by which piece of equipment at what point in time, so that I can identify the vehicles that are impacted. And so that could effectively, now that's a very broad use case, because you can imagine that could go on for a very long time, that's years, and also could involve a number of different participants. So you can kind of pick and choose and slice off a piece of that. But those are some examples, hopefully, that helps here, that give you an idea of where, or the different types of parties that could be involved in such a use case.
Okay, thanks. Another question which comes from one of our SEMI attendees is that how can a trade association like SEMI take advantage of blockchain?
So I would say that a couple of different areas I would suggest, and there could be others. Just a couple of them come off the top of my head. One is further refinement of use cases. So out of the different areas that SEMI looks at, and the different use cases and use case categories, if you will, that are covered by the organization, where and how could blockchain be utilized to augment different problems that members are encountering in each one of those use case categories. So it's more the appropriate use. I also say the use cases where it doesn't really make sense, like what are some guidelines? What are some things that you want to consider when you're looking at blockchain technology? So for example, I mentioned that if you have a network of one, that probably isn't a great use case for you. Maybe to start, because you might just be doing a proof of concept and you want to learn about it. So that would be fine. But there are a certain set of guidelines and considerations that you can go through that say, well, no, I really only need a distributed ledger. I don't need a full blockchain, if you will. Right, so things like that will come up. So some guidelines around when to use it, when not to use it, what do people need to think about, and then also potentially some standards. Right, so if I want to represent an asset, and I want to represent, in this case, it's a particular piece of electronics or whatever it is that's being manufactured, how can I represent the data structure associated with that asset in a way that's standardized across all the different participants? Right? Okay. Otherwise, I'll end up with some, just like with EDI, I had a standard around all the EDI transactions, but then everybody hacked them and they all became customized. And then it took a lot of work to integrate them. You could envision that type of problem also occurring in the blockchain space. So you want to make sure that at least there's some higher level set of standards, if you will, around things like information exchange and data formats, right? That could be another potential example.
Okay, great, thanks. We have an interesting question from Europe. In Europe, of course, we know that we have GDPR, which is changing a lot of things. Yep. One point of GDPR is, as the questioner asks, one point is the right to be forgotten. But if one is in a blockchain network, your work in whatever is in there is there forever and ever and ever, right? Even if this person doesn't want to participate anymore. So how do you manage this?
Right. Yeah, and this is a gray area for sure. So definitely when it comes to personally identifiable information and the different aspects of information that are related to GDPR, you get into this idea of not storing all that information on the blockchain itself, right? Effectively is what you end up with. Now, this is also tricky because GDPR even says that if you take a hash of the data and you store the hash on the ledger, it still represents the data. And so you may not be GDPR compliant. So in the case of things like identity and personal information, this is where you're using blockchain more as a mechanism to effectively discover one another, or to temporarily allow access to maybe your personal information. And then the person can revoke that information, again, using some of the concepts associated with things like public-private keys and so on and so forth. Right, but yeah, definitely one of the things you want to stay away from is storing all that information on the ledger. Right, that does defeat the whole purpose and would cause all kinds of problems with GDPR. You also need to watch what you hash and put on the ledger, because again, that could violate GDPR. So you're now using blockchain more as a mechanism to discover one another and to facilitate the potential exchange of information, but not to store the information. Right, that's kind of the distinction that you want to make there.
Okay, well, that's very helpful. A couple of more quick questions. We have a lot of questions and we're not going to be able to get to all of them. So for the questioners, please rest assured that your questions are not lost. We will forward them to Nelson and you'll probably get a written answer later. But a couple of quick questions, Nelson. Number one, particularly in the manufacturing environment, in the semiconductor manufacturing environment, we find that IP is a huge consideration. Obviously, we wrote the book, right? Only the paranoid survive, and so everybody is very legitimately concerned about their IP, and that creates kind of a chicken and egg problem, that data is not shared for things like preventive maintenance or root cause problem solving and so forth. And therefore, the technologies like blockchain and AI ML are not really used to their full extent because the data is not there. So, is there a way that blockchain, maybe in some ways together with encryption or something, can help address this problem?
You mean in terms of the information sharing itself?
Yes,
facilitate
yes.
that?
Facilitating the information sharing.
Yeah, I mean, potentially. So definitely in terms of, using blockchain as this notion to store, even if you're storing metadata, now again, this would go back to the GDPR, so we got to balance this out, but But the idea being that if you can store metadata about certain types of information and make it easier for people to discover and find and share that information, that blockchain could be used to facilitate that. The consideration here is how much information. So blockchains themselves are not meant to store terabytes of information. So you've got this balancing act between using the blockchain as a mechanism to, first of all, make sure that information is not being tampered with. Second of all, to try and help the fact that you want to make sure that only the right people are seeing the information. And then thirdly, using it as a mechanism to more seamlessly share information, if you will. Now, where that information is stored could be up for debate, right? Because you may not put all of it on the ledger. It's just going to be too big. And so some of that could be stored off-chain. And so that's going to be some storage area. And there's technologies emerging around this, like IPFS and so on and so forth, where that could potentially be used as a secure off-chain store, which is pointed to by data that's on the ledger. So if somebody went to the ledger and discovered some information or was triggered via some sort of smart contract, it would have a pointer effectively to the data that's in off-chain storage. You would retrieve that data, compare the hashes, make sure that nobody has tampered with it, make sure that it's still the right, still owned by the rightful owner, or has been signed by the rightful owner. And then from there, you're assured that the information is what it should be. So there are some aspects that could definitely help. Not some of them are going to be, well, do I really need a blockchain for that? And again, you may or may not, depending on how that information sharing is occurring. But in some scenarios, especially when it gets around the verification, validation, and wanting to record who did what with what piece of information, then a blockchain could help in that regard.
Okay, so we're almost out of time. I'll ask one last question. What is one of the main issues preventing broad adoption of blockchain technology?
One main issue. Well, I'm going to say two, just because it's at the end and I'm giving the answer. So, the technology still needs to evolve. The technology still needs to make it easier for people to adopt this type of technology and also to support the use cases. So whether it's related to performance, whether it's related to data storage and management, whether it's related to how you actually handle the keys, those kinds of things, that needs to evolve. The technology needs to evolve to make that easier. And we see this with all technology. So this is nothing new. Technologies, as they encounter more use cases and as time passes and so on, it obviously get better, hopefully. But the big aspect of it, and I alluded to this a little bit earlier as well, is the idea that it's not just a single party. It's not just one company. I don't know, in some companies that I've been in, even just getting the business units to share and collaborate and exchange information can be challenging. Never mind trying to do that across companies, where you might be a competitor sometimes and you might be collaborating other times. So how do you manage that? How do you set up the structure around that? How do you, again, define what the business logic is going to be and who's going to do what and what's the consensus algorithm? And those are the kinds of things that get complicated. And that actually takes a lot of time. So, I'm going to say there's just two aspects, non-technical and technical. Both of those need to evolve.
Okay, fair enough. Thank you very much. I apologize, we're a couple of minutes over time, but fantastic webinar, Nelson. We thank you very much for doing the webinar, and the slides will be available to everyone who attended or registered. I think you can download it from the handouts, or they will be sent later. And all the questions, as I said, will be forwarded to Nelson. And Nelson, when you have an opportunity, you can address some of the questions that were not asked here because of lack of time. But sure, thank you, everyone. Again, Semi encourages you to engage with us for things like the blogs, the proof of concept projects that we're running exactly in this area of trying to solve some of these problems in manufacturing and so forth. And have a great Tuesday and a great week. Thank you.